This is the instructional review video for writing probability statements. If you have been in my class, you know that this is stressed. P parentheses means what is the probability of? And inside of here, we're always talking about some sort of event. So some sort of desired outcome. And our subset is the numerical value for that desired outcome. And our sample space is the total population that we are looking out of to find this information. So here's an example of a scenario where males and females were surveyed about whether they like chocolate or vanilla best. So we see from this two-way table that 23 females like chocolate and 8 males like vanilla, and so forth. We can see the totals on the margins, and that brings us to our first type of probability statement, a marginal probability statement. Now, you've been doing these a lot without really realizing that there is a title for them. So if we wanted to talk about the probability that someone out of this data were to be a male, we would look at the total amount of males, and there's 14 out of our whole sample space, which was 47 people that were surveyed. Another example of a marginal probability is the probability that someone in this data likes vanilla. Well, out of everyone in the data, out of all 47 people, we see that 18 of them like vanilla. These are marginal statements because they are found along the margin of this data. So you could ask about the total number of people who like chocolate or vanilla, or the total number of males or the total number of females out of everyone. So that is our first type of probability, marginal. Another example of a probability statement that we could write from this data is a conditional probability. So we have perhaps what is the probability that someone is female given they like vanilla. And remember, this bar means in words given. It kind of helps us read this out loud. Maybe out of all the people who like vanilla, how many of them are female? Or again, what is the probability that someone is female given they like vanilla? So vanilla becomes our new sample space. We're looking out of all the people who like vanilla, and we know that there's 18 of them. How many of them are female? Well, 10. Another example of a conditional probability statement could be, what is the probability that someone likes vanilla given they're female? Again, this female is our sample space. It is out of all the people who are female, which of them like vanilla? So we look and we see that there are 33 females, and 10 of them are both female and like vanilla. Now, there's a huge difference between these two probability statements, though they look the same. Though they have the same events, these events are in a different order, so we are now considering the sample space to be different. An interesting thing that you could think of is this might be like the fraction sign or the division sign, and you're taking these two events and sort of flipping them. So we see all of the females, that 33 is our denominator, and the people who like vanilla and are female are our numerator. So this is an example of conditional probability, where the important notation is this given bar. There it is as well. Another type of probability statement is a complement. So the complement is notated by this little apostrophe. This apostrophe in words means not. So we could ask maybe, what is the probability that someone is not female? Well, if they're not female, then they are male. So let's look. Out of all the males, there are 14 males out of the entire sample space. Well, look, that's the same as this statement up here. What's the probability that someone is a male? So using the complement just makes the event flip to its opposite. So we could also ask, what is the probability that someone does not like chocolate? Well, what is not chocolate? Vanilla. So we know that 18 out of 47 people like not chocolate or vanilla. Well, that's the exact same as this kind of statement up here. Let's do one more. What is the probability that someone does not like vanilla? So we'll go to vanilla and look at its opposite. That's chocolate. There's 29 out of 47 people that like not vanilla or chocolate. Now, we could talk about how these two numbers add up to the total amount of sample space. If something is vanilla, if someone likes vanilla, then they are notated this way, but if they do not like vanilla, then they are the opposite. Well, 18 plus 29 is 47. If you add up the total number of people who don't like vanilla and the number of people who do like vanilla, that adds up to the sample space. And we can talk about that in a bit. So there's a little review on complements. Now, another probability statement that we could talk about is a union. And that notation is a U. U for union. We could talk about the probability that someone likes chocolate or is male. Now, this notation means or. So the probability that someone likes chocolate is male. Well, we would look at all of the people who like chocolate. So we know that there's 23 females that like chocolate. And there's 6 males that like chocolate. So that's all the people that like chocolate. Let's look out of all the males. Well, we've already counted that 6. And we know that there are 8 other males in this survey. Doesn't matter if they like vanilla or chocolate. We're just looking for the condition that they are chocolate or male. So out of the total number of people that were surveyed, 47, we know that 23 plus 6 is 29. 29 plus 8 is 37. So we know that 37 people either like chocolate or are male, because these people like chocolate and these people are male. So we just added up these 3 numbers that matched these 2 topics. Let's do another example. The probability that someone is male or likes vanilla. Well, we know that the probability that someone is male is either 6 or 8. And what about the people that like vanilla? Well, we know that 8 males like vanilla, but we've already counted them. And we know that 10 males like vanilla. 10 females like vanilla. So we know that 10 plus 8 is 18, plus 6 is 24. So we know that 24 people total are either male or they like vanilla. This is an example of a type of probability statement that is a union. And our last probability statement that we have learned about involves an intersection. And here's its notation, a big N. And this N stands for and. Now I know I was saying and back here a little bit, but I didn't mean that because this type of notation indicates and. So if we wanted to talk about the probability that someone is female and likes chocolate, well, we look for just the person that is female and likes chocolate. We're not talking about both. We're not talking about or. We're talking about just female and likes chocolate. And only 23 people fit that condition. Another example is the probability that someone is female and likes vanilla. Well, these 10 people meet both of those conditions, and that alone is what we are asking for. So the only difference between intersection and union is that union is more inclusive. If you were talking about chocolate and male, well, you could talk about all the people that like chocolate or are male. But if you were talking about and, female and chocolate only refers to the people that fit those two conditions. So we have 5 different types of probability statements. They all use a different notation or do not use notation at all. Marginal just refers to the people that are on the margins, the total numbers. Complement uses this notation, a little apostrophe, which means not. Conditional has the conditional bar, which means given. Union, we're talking about something or another thing, indicated by the U, and an intersection means and we're talking about only 2 conditions being satisfied at one time.